Now we go for divergence. What is the meaning of divergence? If the delta V tends to 0, in previously we applied differential volume element, if limit delta V tends to 0, if the volume element tends to 0, what is the electric flux density or any vector? Limit delta V tends to 0. Suppose if the tube is there, if any tube is there, air pressure, if a hole happen in the tube, entire air will be comes to this hole. That is the divergence, means if the volume tends to 0, what is the vector reached to that? If divergence at P, divergence of a tube, a punctured tube may be assumed as a divergence, air under pressure, it is a divergence means when delta V tends to 0 by applying the Gauss law for differential volume element. Let us see that divergence. As we applied already the Gauss law for differential volume element, we obtain the equation is Q equal to dou dx as we applied already for differential volume element. If you apply the Gauss law, we obtain the equation the total charge enclosed in a differential volume is given by Q equal to surface integral d dot ds equal to dou dx by dou x plus dou dy by dou y plus dou dz by dou z. This we obtained previously, where delta V tends to, what is delta V? Delta x, delta y, delta z. Three coordinates product, a small length we assumed. That is make it as equation number 1. To obtain divergence, we have to obtain delta V tends to 0. Limit delta V tends to 0 if you apply for a small length, for a small portion, for a small volume. If you apply delta V tends to 0, limit delta V tends to 0, we can get divergence. This is the charge enclosed in a small element, differential volume delta V. This is the total charge. But from Gauss law, Q can be written as surface integral d dot ds. From the Gauss law, we can make it as equation number 2. To apply Gauss law, we have assumed that differential volume element as the Gaussian surface, for which d bar is constant. Hence, we can equate equations 1 and equation 2. We can equate in limiting case, that is delta V tends to 0. We are applying limit delta V tends to 0. That is surface integral d dot ds equal to limit delta V tends to 0 dou dx by dou x plus dou dy by dou y plus dou dz by dou z into delta V. We can equate and we can apply the limit delta V tends to 0. To apply Gauss law, we assume the differential volume element as Gaussian surface, over which d bar is constant. Now we can equate 1 and 2 equations. In limiting case, that is delta V tends to 0. Okay, by applying delta V tends to 0, now send the delta V to right side. We can write, therefore we can write dou dx by dou x plus dou dy by dou y plus dou dz by dou z. Only we can write limit delta V tends to 0, limit delta V tends to 0, that is Q by delta V. We send the delta V side to this side, Q by delta V. We can write Q as we can write Q as, in Gauss law we can write surface integral d dot ds. What is Q? Surface integral d dot ds we can write in place of Q. We can write like this, divided by delta V, where limit delta V tends to 0, surface integral d dot ds by delta V. Thus, in general, if a bar is any vector, not only d bar, say force, velocity, temperature or the vectors, temperature gradient or the vectors, then we can write in place of dx we can write dou ax. Assume that A is a vector. Vector may be velocity, force, temperature gradient, force, velocity, like that. we can write dou ax by dou x plus dou ay by dou y plus dou az by dou z equal to, this is limit delta v tends to 0 a dot ds. We can write like that. This mathematical representation on a is called divergence of a, or divergence of d bar can be written as, let us see that, divergence d bar can be written as limit divergence of d bar, it is divergence of d bar is limit delta v tends to 0 surface integral d dot ds divided by delta v, that equal to dou dx by dou x plus dou dy by dou y plus dou dz by dou z. This is the divergence of d bar. Similarly, we can write divergence of a bar also. In place of d bar, we can substitute a bar. That is divergence of any vector is limit delta v tends to 0. We can write in place of d bar, we can write a bar also. A bar may be any vector. Limit a dot ds divided by delta v. That is dou ax by dou x plus dou ay by dou y plus dou az by dou z. It is known as divergence of a bar. Any vector, divergence of any vector is partial differentiation in all directions is known as divergence. But we have to apply limit here. Limit delta v tends to 0. If you apply the partial differentiation, then we can obtain what is the formula for divergence of any vector. Any vector is divergence of a. Divergence of a bar equal to limit delta v tends to 0 surface integral a dot ds by delta v, that also equal to dou ax by dou x plus dou ay by dou y plus dou az by dou z. It is the divergence. The physical meaning of divergence is all the charges, if comes to a limit delta v tends to 0, వాల్యూమ్ తక్కువ అయినప్పుడు ఆల్ ద చార్జెస్ ఎలా వెళ్తుంటాయి అనేది డైవర్జెన్స్. ఫిజికల్ మీనింగ్ ఆఫ్ డైవర్జెన్స్. ఒక పంక్చర్ అయింది అనుకోండి ట్యూబ్, గాలి అంతా ఒక హోల్ గుండా వస్తుందండి, అంటే వాల్యూమ్ అన్ని చార్జెస్ అన్ని ఎయిర్ పార్టికల్స్ కమ్స్ టు వన్ పోర్షన్. దట్ ఈస్ నోన్ as కాన్సెప్ట్ ఆఫ్ డైవర్జెన్స్. The air velocity is the function of distance and hence divergence of velocity is positive. The density of lines near hole is high, showing the higher velocity. The source of such velocity lines is throughout the tube and hence always inside the tube any point on divergence is positive. Again we can see from the what is divergence. A divergence means we already know that the total charge enclosed from the Gauss law for a differential volume element, dou dx by dou x plus dou dy by dou y plus dou dz by dou z delta v. That is the make equation because we already derived for differential volume element. According to Gauss law, q equal to surface integral d dot ds. That is the equation 2. Therefore, surface integral d dot ds equal to, we can equate the equation 1 and 2 by taking a limit delta v tends to 0. That is surface integral d dot ds equal to limit delta v tends to 0 dou dx by dou x plus dou dy by dou y plus dou dz by dou z, that is into delta v. Why we applied delta v tends to 0, limit delta v tends to 0? If the volume tends to 0, then it is known as divergence. Thus we can write thus divergence of d bar or any vector is limit delta v tends to 0 surface integral a dot ds by delta v, that also equal to dou ax by dou x plus dou ay by dou y or plus dou az by dou z. You can write in place of ay also any vector it is, maybe electric flux density also. The mathematical operation on a bar is called as divergence. The divergence of a bar is, this is the formula. Again rewriting that, we can write divergence of a bar, divergence of any vector, that may be electric flux density also, divergence of a bar equal to limit delta v tends to 0, limit delta v tends to 0, we have to apply, that is surface integral a dot ds divided by delta v, that equal to dou ax by dou x plus dou ay by dou y. We have to substitute, that is dou ax by dou x plus dou ay by dou y plus dou az by dou z. We can write like this. This is called divergence. The mathematically divergence is given by divergence of a. Divergence of d means a, in place of a we have to substitute d bar. That is the divergence theorem. If you apply divergence theorem, divergence of d bar can be written as, now we can see that divergence of d bar. We already know that surface integral d dot ds, we already know that according to differential volume element, surface integral d dot ds equal to dou dx by dou x plus dou dy by dou y plus dou dz by dou z into delta x, delta y, delta z, that is equal to q. Now dividing the above equation with delta v, divide above equation by delta v, it is equation by delta v, and taking the limit as delta v tends to 0. Now we can take surface integral d dot ds divided by limit delta v tends to 0, and divide with delta v, that equal to, if you divide with delta v means delta x, delta y, delta z. If you divide both sides and apply the limits, delta v and delta x, delta y, delta z, also known as delta v, we can get cancelled. These two will be cancelled. Delta x, delta y, delta z is also known as delta v, we can cancel each other. That is surface integral d dot ds by limit delta v tends to 0, and delta v is given by dou dx, only this term will come because all this will get cancelled. Dou dx by dou x plus this we can write here because already it is cancelled. It is also known as, if you apply the limit delta v tends to 0, d dot ds, it is known as divergence of d bar. Divergence of d bar equal to dou dx by dou x plus dou dy by dou y plus dou dz by dou z, that is dou dx by dou x plus dou dy by dou y plus dou dz by dou z. We can write like this. That also equal to rho v, volume charge density, rho v. The differential volume having charge density, it is known as rho v. This is called divergence of d bar equal to rho v, is called Maxwell's equation. The Maxwell's first law is given by divergence of d bar equal to rho v. That is the Maxwell's first equation. We have to remember what is the Maxwell's first equation is. The Maxwell's first equation is divergence of d bar equal to rho v. Limit, why we can say that rho v, it is limit delta v tends to 0, q by delta v is also known as rho v, previously what we obtained. Similarly, limit delta v tends to 0, surface integral d dot ds by what we obtained previously. Limit delta v tends to 0, surface integral limit delta v tends to 0, surface integral d dot ds by delta v, also known as, if you do this integration over carried out delta by surface integral d dot ds by delta v, limit delta V tends to 0. If you do this, it is also known as rho V we can obtain. Similarly, divergence of d bar equal to rho V. This is the Maxwell's first law or point form of Gauss law. It is very important to know that divergence of d bar equal to rho V, or divergence of a bar also is known as rho V. This is the volume charge density around a point. This equation is called Maxwell's first equation. This equation is known as Maxwell's first equation. What is Maxwell's first equation? Simply divergence of d bar equal to rho V. The equation is called Maxwell's first equation for electrostatics. This is also called point form of Gauss law or Gauss law in differential form. The statement of Gauss law in point form is the divergence of electric flux density in any medium at a point differential volume shrinking to 0 is equal to volume charge density at the same point. The statement is like this. The statement of Gauss law in point form or Maxwell's first equation is divergence of d bar equal to rho V is the Maxwell's first law. It is in the point form of Gauss law also it is. It is the Maxwell's first equation, point form of Gauss law or differential form of Gauss law. We can say that divergence of a bar equal to rho V also. Divergence of a bar means del dot d bar equal to rho V, where del is partial differentiation dou dx by del means dou by dou x plus dou by dou y, dou by dou x plus dou by dou y plus dou by dou z. It is the partial difference. Del operation means dou by dou x plus dou by dou y plus dou by dou z. That is the partial differentiation. Del dot d equal to rho V or del dot d equal to rho V or divergence of d bar also known as rho V. Divergence means partial differentiation dou by dou x. Now the divergence theorem says that we go for divergence theorem. In cylindrical coordinate system, the divergence is divergence d bar equal to, we have to apply not a partial differentiation for cylindrical coordinate system and spherical. Del dot d equal to rho V is known as del dot d rho V is also called as del dot rho V, del dot d bar equal to rho V is also called as Maxwell's first law, or divergence of d bar also known as rho V. It is also Maxwell's first law. Now we go for divergence theorem. We have from the Gauss law surface integral d dot ds equal to q, that is rho V dv we can write. What is divergence theorem? Let us see. Now we go for divergence theorem. The divergence theorem can be used to find Maxwell's first law, del dot d equal to rho V. The Gauss law, from the Gauss law we are obtaining divergence theorem. We have, according to divergence theorem, from Gauss law we are deriving the divergence theorem. According to Gauss law, what we can write? Surface integral d dot ds equal to q, or q equal to surface integral d dot ds. This is the Gauss law general equation. While the charge enclosed in a volume is given by q can be written as in volume charge, while the charge enclosed in a volume is given by in volume charge. While we discussed about different charge distributions, we can write q as in terms of v, volume integral rho v dv we can write. How? Rho v means total volume by total charge into dv. It is total volume by total charge, total volume by total charge into dv. Then volume get cancelled, then we will get total charge q. It is a small volume, but we can assume that it is a volume. It is a volume with cancel, we will get q. Hence it is q. We can represent total charge enclosed in a volume is given by while the charge enclosed in a volume is given by q equal to volume integral rho v dv. But according to Gauss law in the point form, that is Maxwell's first law, according to Maxwell's first law or Gauss law in point form. What is the Gauss law in differential form or point form? According to Maxwell's equation or Gauss law, according to Gauss law in point form, we can write, according to Gauss law in point form, we can write del dot d bar equal to rho v. Okay, make it as equation number 1. According to Gauss law, it is, we can represent q in volume charge density, it is, make it as equation number 2. Now, but according to Maxwell's first equation, divergence of d bar or del dot d bar equal to rho v. Make it as equation number 3. Now, using equation 2, now substituting the equation 2, now using in equation 2, q equal to volume integral rho v in place of 3 equation we are substituting in this equation. Volume integral rho v can be written as del dot d bar into dv. Okay, we can substitute like this, dv. From equations, make it as equation number 4. The first equation is from the Gauss law, q equal to surface integral d dot ds. If the charge enclosed in a total volume is given by, q also can be written as, in terms of volume charge, volume integral rho v dv we can write. Make it as equation number 2. According to Maxwell's first law or Gauss law in point form, already we derived del dot d, divergence of d bar equal to rho v. Make it as equation 3. Now substitute this in equation 2, q equal to volume integral rho v can be written as del dot d bar into dv. Make it as equation number 4. Equating the 1 and 4, let us see now. Equating 1 and 4, 1 equal to 4, if you may equate, the one equation is surface integral d dot ds equal to volume integral del dot d bar dv. This equation is called as equation 5. Assume that this equation is called as divergence theorem. It is also called Gauss-Ostrodesky theorem. This theorem can be stated as it is the divergence theorem. Surface integral can be converted into volume integral. You can see what is the purpose of divergence theorem is to convert surface integral into volume integral. The integral of the surface integral can be written as surface integral d dot ds equal to volume integral del dot d dv. The main purpose of divergence theorem is to convert surface integral into volume integral. That we have to remember. This theorem can be applied to any vector field. Partial differentiation of that field must be exist. The divergence theorem is applied to flux densities both sides. Divergence theorem can give net charge enclosed by the closed surface. With the help of divergence theorem, the surface integral can be converted. Into volume integral, provided that closed surface encloses certain volume. The points to remember is, how can we obtain divergence theorem? Let us see. We obtained for differential volume element previously, that we have to see in this video. First, we applied according to Gauss law, the total charge enclosed in any closed surface equal to surface integral d dot ds. That is, make it as equation number 1. we can write q in volume charge density is volume integral rho v dv. We can write, already we saw that in different types of charge distributions, or we can say that what is volume charge density? Total volume by total charge. Total volume by total charge into volume, you can get, again you will get q. Make it as equation 2. According to Maxwell's the first law, that is divergence of d bar equal to rho v. Divergence of d bar equal to rho v. Make it as equation 3. Substitute equation 3 in equation 2. Q equal to rho v, that is volume integral rho v. In place of rho v we can substitute del dot d dv. Make it as equation number 4. After that we obtain equating 1 and 4 both are equal, that is surface integral d dot ds equal to volume integral d dot del dot d bar dv. This is the divergence theorem. What is the main purpose of divergence theorem is surface integral can be converted into volume integral. The main purpose of divergence theorem is surface integral can be converted into volume integral. That is the key point. Surface integral, that is surface integral can be converted into volume integral, whatever be the vector. Surface integral a dot ds equal to volume integral del dot a bar dv. We can obtain whatever be the vector it is. Divergence theorem, it is on surface integral, volume integral we can convert easily by using the divergence theorem. While solving the problems, next we go for how to solve divergence theorem problems. Proof of divergence theorem, how to solve divergence theorem problems.